Good morning, students. So, in this class, we will study what is the problem of degeneracy and how to resolve it. Okay. In order to understand this, I am taking an example here. Suppose this is the problem: maximize z is equal to this subject to constraints. Let us take less than equal to type of constraints. But if even if these are of mixed type, so there is no problem. We will proceed as usual with the simplex method. First step here is just to find out the standard form. So using standard form with the help of slack variables, and initial basic solution is obtained as usual as this S1 12, S2 8, and S3 8. Then we make a simplex table here. In the simplex table, we write all these values as usual, and then we find ZM and CG values. So minus most negative is S1 will be entering, and which is moving. For that we find enumeration 12.4, 8.4, 8.4. So we get 3 to 2. Now there is a tie in removing the variable out of the basis because there are two minimum ratios. So there is a problem. If we continue with this, we may not reach an optimal solution. We may caught in cycling. Okay, so to remove the degeneracy, this is the indication of degeneracy in the MPP, and if we remove it, there is a method given by Charney. So if we remove it, we will definitely reach an optimal solution. What is the way out? Which is the method? So rearrange the columns in the table so that variables forming the basis come first and other variables. So this is what I did. Now I am putting these S1, S2, S3 first, and then the other variables X1, X2 here. Okay. What is the next step we have to do? Now we don't have to divide the B values. We have to divide the variables under the values under first slack variable. Okay, so here we have not to bother about these three. We have to bother about these two because these are equal. So again, what to do? Divide the values under S1. So 0 by 4 and 0 by 4. Again giving me same tight minimum ratios. And then I have to go for other variable S2. Okay. So here 1 by 4 and 0 by 4. If I do it, I get 0. So now I am able to find out the minimum ratio. Okay. Suppose the minimum ratio is not possible here. We will have to move to other slack variable and till we get the minimum ratio. Okay. So now again we have uniquely determined the variable to move out of the basis and variable entering into the basis. Again we have to convert all these rows, first row and second row and then the third row by usual method, that is this is the key row, divide all elements by key element. Okay, for all other rows the same procedure will be applied, that old row minus element in front of the key element multiplied by new key row. The same formula will be applied, and we get a new table like this. There are some these settings, but we can see this is 0, this is 1, this is minus 1, this is 1, and this is 0. Okay, please note it. This is minus 3 by 2, and all these values we can see here. So when we find the minimum ratio, this ratio is getting negative. So I have already told that the negative and infinite ratios will not be considered. So considering only these two, out of these two, this is minimum. So this variable will move out and this will enter the basis. Again, we will go for next table, and the next table we see that this ZJ minus CJ again 1 is negative. Again we have to go further. So this variable will enter into the basis, and now this minimum ratio corresponds to this 4 and 16. This 4 is minimum, and this S1 will move out of the basis. Again we do the same procedure and we get this table. So in this case all ZJ minus CJ is equal to 0, and these are now the values. There is no need of finding the minimum ratio because all ZJ minus CJ is equal to 0, and these are the values. X1 equal to 3 by 2, X2 is equal to 2, and I have written here also, and maximize z is equal to 5. So this is my optimal solution, and I told you how to remove the tie in the variables to be ordered. This is a rough work, and you can refer to how the new rows are obtained. Okay.